Okay, we have here to another integral from Caltech Math Meet 2025, number 14. We have the integral from minus infinity to infinity, e to the minus x squared plus 3x dx. Okay, you may recognize this as something that looks kind of like we can use the Gaussian integral on it. The only trouble is we've got this plus 3x here, right? If it was just e to the minus x squared, cover that up right there. And this thing without that would be just square root of pi. But unfortunately, we do have that plus 3x, so we can't just go right to our solution. What we can do, though, is we can take this exponent and we can factor it. The first thing I'm going to do is just take the minus sign out just to make it more convenient. So I'm going to write it as minus times x squared minus 3x. Then what I can do is complete the square. So what you do is take half of the coefficient. So we can write this as x minus 3 halves and just square it. Doing that out, we're going to get back x squared minus 3x. Then for the last term, when we square that, we get plus 9/4. We don't want to change it, so we just subtract off the 9/4. We'll just throw the minus sign back in there so we can have it and split it up. So it's going to be like this. Distribute the minus in here. It's going to be plus 9/4. Now this thing is all in the exponent for our e, okay? So then by exponent properties, we can actually split this up into two terms. We can have it as this first one like this, and then we can have a second term with e to the 9/4 like this. But e to the 9/4 is just going to be a constant. So when we take this, we can put it back in the integral, but the e to the 9/4 is going to come up front. So when we do it, we'll have e to the 9/4, same bounds, minus infinity to infinity. Now we just have a different exponent, e minus x minus 3 halves, all squared. Now, in some ways, you may think this is more complicated or just as complicated, but actually, we're basically done at this point. What I'll do just to show it, you don't have to, is we can do a u substitution on this right here. I just want to get it in exactly the right form, but you could skip this step at home if you want. So when you differentiate it, it's going to be 1. And that's why it's not necessary, because you end up with the same du and dx. So when you do this, you have the constant out front. It's still going to be going to infinity. The bounds aren't going to change by 3 halves. Infinity doesn't care about that. Infinity doesn't care about your 3 halves. So then it's going to be e minus u squared du. But now again, this is exactly our Gaussian integral. This thing is going to be square root of pi. So putting it together, we have e to the 9/4 times square root of pi. I think I'll try to write it a different way, even though this here is fine. But we could bring it all under one square root and do it like e 9/2 times pi like this. Or then with the 9/2, we could turn that into another square root. So I guess I'll leave it. You could do this a million different ways, but I'm going to write it for my final solution, square root of pi times square root e to the 9th, and that's it. Not sure, but I think Caltech Math Meet actually wrote it this way, so of course my way is better. No, I don't know. There's no better or worse here. It's all the same stuff. So anyway, that's it for today. Thanks everyone for watching. Have a good day.